Hello, everyone. How are you guys doing today? Good. I'm glad to hear that. Let me start with the news about exam. Our exam will be exactly 3 weeks from today on December 3rd. Before that, we have 4 more classes. So today is 12. We have a class today and on Friday. Next week we have Tuesday, Friday. Then next week we have Tuesday and Wednesday. So on 27, we have a Friday schedule. We are going to have a class on Wednesday, November 27. And then we have Thanksgiving break. But 2 days, if you include the weekend, then 4 days. Okay. And our exam will be December 3rd here. So including today, we have 6 lectures. Except for today, we are going to have 5. 1, 2, 3, 4, 5. Cool. You guys are lucky. You'll have 5 lecture days. My morning class, they will have 4, but you have 5. Not bad. So we are going to have exam on the 3rd based on chapter 12 and 13. And then after the exam, we are going to have 1, 2, and probably 13. Do you know what's the last day of class? 13. So we have 3 more days. I'm going to prepare you for the final exam. If you fail the final exam, all the hard work you did throughout the semester will be in vain. Failing the final exam means failing the class. So I would like to take some time to prepare you for the final exam. So 3 days, a good days, a good time. Besides, if you cannot finish everything, chapter 13 and 12 before the exam date, then I'm going to do them after exam 3. But for now, my plan is to give you the exam on 12 and 13. And if you notice, I already posted the review sheet on Blackboard. Sorry, not Blackboard, we have Brightspace. And this time our review sheet has lots of materials. Exam 3. So it has so many things. We have already done it 12.1 and 12.2. Then we have 3, 4, 5, 6, 7, 8. And we are going to have word problems. Then we have logarithm, log. And 13 is circle, distance. 13.3 is solving nonlinear equations. You see, a lot. So this exam will be a big exam. Final exam is exactly 5 weeks from today. 8 a.m. in the morning. 2 hours. Final exam will be 17. December 17, 8 a.m. in the morning. 2 hours. It will be 2 hours long, 30 questions. 1 hour, 30 minutes is for non-calculator portion and 30 minutes for calculator portion. Oh, and our second exam will have a calculator portion. So let's say 1 hour, we have 1 hour, 40 minutes. So 1 hour, 20 minutes for non-calculator and 20 minutes for calculator portion. You don't have. We do on December 3. December 3 will be our 3rd exam based on chapter 12 and 13. And December 17 will be our final exam based on everything. Okay, so start working on your review sheet. If you know the materials, you know how to do all the questions. And good news is that for many of the questions, I actually also post the answer next to the question, so you can check your work. For most of them, not for everything, for most. So we have a lot to cover before our next exam. And today we'll start exponential. We are going to learn all about exponential. Probably it will take us 2 lectures to finish exponential, and then 2 lectures to finish log. And then most likely this time we can have a review for the exam, before the exam. Okay, any question? I didn't make the exam yet, but from the review sheet, I can already see there will be a lot of questions. Definitely less than 30. Final exam will have 30 questions, 2 hours. We have 1 hour, 40 minutes, so definitely less than 30. But how many? I'm not sure yet. 30 questions, 2 hours. 24 in the first portion, and 22 in the first portion, non-calculator, and 8 calculator questions. So don't forget to do all of your homework and quizzes. Homework and quizzes are almost 20% of the grade. Especially if your in-class exam scores are lower, that means you have to have all 20% in your homework and quizzes. That will balance up your average at the end. Okay. So in 12.1, we talked about composition. In 12.2, we talked about inverse. And now in 12.3, we are talking about exponential. Exponential function, the equation has a format, some type of leading coefficient a, and then we have a b with the exponent power x. So the difference between all the things we did so far and the exponential is that all these times we had polynomial to work with, and polynomial had x as a base, number as a power. So it grows slowly. But for exponential, it's other way around. Our number is the base and x is the power. So exponential function, they grow really fast. And just like the parabola or linear function, we had some type of leading coefficient. Exponential also has some type of leading coefficient. So if you're finding the equation of the exponential function, you also need to find what the leading coefficient we have. And our base, it must be a positive number. If the base is bigger than 1, we have a growing exponential function. And if our base is a fraction, then we have a decreasing exponential function. So it cannot be negative, our base, it has to be positive, and whole number gives us an increasing function. Fraction gives us a decreasing function. We have a special type of base, we call it E. E is a number more than 1. It's 2.71, blah, 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 blah. And it's a special number. It helps us solve many, many questions in physics, in math, probably also in chemistry. I don't know. I forgot. But in physics and in math, E is a very special number. It helps us a lot. So sometimes you will see your base as just a number like 2, 3, 4, 5, 6, those numbers. Or sometimes you will see your base as an E. E means it's a number that is more than 1. Okay? So it will give us an increasing function. Evaluating exponential function is same as evaluating normal polynomial. We replace x with the given numbers, and then we apply exponent rules. So exponential means there are some type of exponent rules you're going to deal with. So on the right page, we have f of x is 5 to the power x. In here, what is our base? 5. So they want us to find f of -2. It means 5 to the power -2 because our x is -2. And now you're going to use the exponent rule. Previously, you learned if x has a negative power, how can you convert? 1 over the positive power. So what is 5 to the -2? 1 over 5 to the positive 2. That gives us 1 over 25. So we substitute x to the given number, and then we apply the exponent rules. How about the next one? F of 0. 5 to the power 0. And do you remember your rule? Anything that is not 0 to the power 0 gives us what? Huh? No. 0 to the 0 is undefined. Not 0, it's 1. Anything raised to the power 0 is 1. How come you already forgot all of your rules? So anything to the power 0 is 1. That tells us what is 5 to the 0? 1. 0 to the power 0 doesn't exist. 0 power will never going to give you 0. 0 power never gives you 0. F of 2 means we have 5 to the power 2. And what is 5 to the power 2? 25. Just like normal function, we substitute x with the given number, and then we simplify. In here, to simplify, we use rules, exponent rules. Dua. If the exponent is negative, we can go back fraction. Now the shape of the graph. When we have our base bigger than 1, our function goes upward. So it starts from the left, it crosses the y-axis through the y value 1, and then it goes up really fast. On the other hand, if your base is a fraction lying between 0 and 1, then you have the same shape, but this time it's going down. And still it crosses through the y value 1. You must remember that exponential function has a y-intercept 1. Because when you do shifting, we shift that point, that y-intercept, to move that around. That's how we figure out the shifting, the transformation. So you must remember our y-intercept is 1. For whole number, it goes upward. For fraction, it goes downward. And there is a line that it cannot cross, never. For the original function, we can never cross the y-axis. Y-axis has an equation y equals 0. That is our horizontal asymptote. Horizontal asymptote means it's a horizontal line that the graph is not allowed to cross. So the exponential function, the original one, they have to lie above the x-axis. Same thing this one. We cannot cross the x-axis, so horizontal asymptote is y equals 0. Since our asymptote is horizontal, so when you have a transformation, that asymptote, we get it from the up-down transformation. If your graph shift upward, your horizontal asymptote will be y equals how many units you're moving up. If you go downward, your horizontal asymptote will be y equals that many units you go downwards. So horizontal asymptote is your up-down shifting. You also must remember that. In the exam, you will be asked this question. Find out what's the horizontal asymptote. So you're going to write y equals some number. For example, in here, what is your base? 2. Since it's more than 1, so what would be the shape of the graph? Upward or downward? Upward. Upward. So we have x-axis, y-axis, x-axis, y-axis. The original one always goes to the y value 1. So this is 2 to the x. Our base is a whole number, so we're going to draw an upward graph. My axis to be, too far from 2. What would be our horizontal asymptote? Which line we cannot cross? This line, right? The x-axis. X-axis has an equation y equals 0. For the next one, what is our base? So it's a fraction. That means we are going to have a downward graph. So the left goes up, the right goes down, and still we cannot cross the original one. Sorry, cannot cross the x-axis. So we have the same horizontal asymptote, y equals 0. So we didn't any transformation here yet. We only showed if our base is a whole number, we get an increasing exponential graph. And if our base is a fraction, we get a decreasing exponential function. Dua. Asymptote. We cannot cross the x-axis. So what is the equation for x-axis? We cannot cross the x-axis because exponential graph has to lie above the x-axis. It's always positive. Without transformation, it doesn't. But with the transformation, we move around everywhere. Is there going to be an example where So when we don't have a transformation, our asymptote is y equals 0, which is the x-axis. However, we are going to have a transformation. So here we are saying that every exponential graph, they must have a horizontal asymptote. And that asymptote we get from the up-down transformation. So we have an equation y equals some number. Y equals what number? That is what we get from the transformation. So just like the previous transformation, after seeing the original function, if you have a number extra, you're subtracting, you are moving which direction? Down. Left, right goes inside the function. After the function, if you see a number, it means up, down. So minus means down, and plus means which direction? Up. So see, we moved up and down. So that tells us what is our asymptote. It's y equals -1 and it's y equals +1. So before even graphing the graph, we can already see what line we cannot cross because we know our up-down shifting. And now let's draw the graph here. The first one says y equals 2 to the x minus 1. Second one says y equals 2 to the x plus 1. So the original graph always goes to the y value 1. And since our base is 2, are you going to draw an upward graph or downward graph? Upward. So this is original 2 to the x. Two to the x. Now we already know that this one we cannot cross y equals -1 line. So y equals -1 is here. So this is our boundary, y equals -1. This is the line we cannot cross. Our graph has to be above this line. So if it's above this line and we are going 1 unit down, so what we do, we take this y-intercept and we shift 1 unit down. So where our new y-intercept will be? 0. It's going on 1 unit down. So we draw the new graph here. So the new graph will start at -1, but the -1 line we cannot cross. So we are going to start above -1. And then we keep going upward. The y-intercept will be 0. And then we keep going upward. They always start at 1. They always go through. The original one always goes to y value 1. So this is 2 to the x going 1 unit down. For the next one, we cannot cross y value 1. Y value 1 is here. That means our graph has to lie above that. So we are shifting this y-intercept 1 unit up at 2. So our graph has to lie above that. So 2 to the x plus 1. So when you draw, we always draw the asymptote and our graph lying either above or below, depending on the transformation you have. Any questions so far? So you must memorize the shape. For whole number, it's going upward. For fraction, it's going downward. Try the next one by yourself. What is E? Is it more than 1 or less than 1? More than 1. So if it's more than 1, what type of graph you're going to draw? Upwards. We have a number, a special number E. Its value is 2.7 dot, 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 dot. It's a special number, just like pi. Do you know what's the value for pi? 3.14. So same thing, E is a special number, just like pi. What? So draw the asymptote and the original graph and the transformation. It has the same shape, E and 2, they both are more than 1. As long as you have more than 1, it has the same shape, it goes to the y value 1. The difference between the numbers are, the bigger the number, the narrower the graph gets. So if this is 2 to the x, then 20 to the x will be here. The bigger the base, the narrower it gets, the closer it gets to the y-axis, but still it goes to the y value 1. That's the difference between having a different base. This is e to the x, e to the x. And now draw your transformation. And in the final exam, you'll have at least one of these.
So the top of the arrow there, doesn't have to be in the same range as the amount of E on that. So like the amount of E is 2.7, something like that. So does the line have to be in range with 2.7, or do you just kind of draw it up?
Simply draw it.
Draw it up.
For now, in this class, we don't care about the base. As long as the base is a whole number, this is the shape. And this is always 1. Ready? So what is the horizontal asymptote for the first one? Y equals -1. So this is the line you cannot cross. And then how are you going to draw the new graph? E to the x. It goes down 1 unit. So what's the new y-intercept? 0. E to the x minus 1. My shape look weird. They can touch. Sorry, E to the. So for the right side, what is our horizontal asymptote? Y equals 1. Remember, in the exam, for horizontal asymptote, there will be 2 points. If you don't write y equals, you are going to lose 1 point. Because horizontal asymptote is not a number, it's an equation. Like that. Exactly. Axis of symmetry is a vertical line, and horizontal asymptote is a horizontal line. So axis of symmetry divides the graph into 2 pieces, and horizontal asymptote is a wall. That wall we cannot cross, we cannot break. So this is our wall, y equals 1. So our graph has to lie going up, so above that. So this point becomes 2, the y-intercept. Depending on your shifting. The more up you go, that place becomes senior asymptote. The more down you go, that becomes senior asymptote. So e to the x plus 1. y equals 0 because x-axis. What is the y value in the x-axis? 0. Try this one, this two. But what is your base here? One half, so it goes down. Go ahead. I don't know which side goes down from there. The left goes up, the right. I mean, you start from the left. From the left, you are going downward forever. From the left, you are going downward forever, but you cannot cross the x-axis. That's the original one. And now make the transformations. One, two, three, four. So this is -4. And this is a new wall, new boundary. Go ahead, Stephanie. So I put it crossing through -3. -3, perfect. So you're going, let me change the color. 1, 2, 3, 4. You are shifting 4 units down. This is a new y-intercept, and then it's decreasing forever. So the new person to ask himself is 4 for the transformation. -4. -4. Because you're moving 4 units down. I thought it was the line of process. But it's the number of units. The horizontal axis, that is how many units are going down. So you're going 4 down, so I think that is y equals -4. Now from 1, when you go 4 down, you end up being on 3. This is a y, you're going 3. But for asymptote, it's this one, 4. So you're going there forever and ever and ever. You're never going to go down y equals 94. How about the next one? Asymptote is? So 1, 2, 3, 4. This is the 4. So our graph has to lie above that. 5. So you're shifting this one 1, 2, 3, 4. You end up being at 5. Stephanie. So that one crosses the line? No. Oh, no, but yes. We are going to cross 5 on the y-axis, but then it will never go below y equals 4. You don't know why every time we cross 1? The y-intercept is always 1. Do you know why? When x is 0, what is anything to the 0 power? 1. Same thing here. E to the 0. What is anything to the 0? Again 1. So it doesn't matter what is your base, as long as it's not 0, your y-intercept is always 1. Because anything to the power 0 is 1. And that's what you're proving that x can be 0. 。 . 。 . 。 . 。 . 。 . . . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 。 . So we did up-down shifting, and now comes left-right shifting. So just like our parabola, if you have a number next to the x inside the parentheses, it represents left-right. In here, we don't have to write the parentheses. It's a number on the power next to the x. If you have a number next to the x on the power, it means you're going left-right. And you're doing the same rule. You're following the same rule. Negative means what? Right. Remember, left, right is the bad one, the spoiled one. It doesn't listen to what we tell it to. So -1, we should go left one, but actually go the right one. And +1, we should go right, but actually go left. And what is our asymptote here? Are you going up, down? No. So when it don't go up, down, what is our asymptote? 0. Because we are not going up, down. If you go up, down, that our asymptote will be that number. Since we are not going anywhere, so it's 0.
What if it was 2 to the power of x plus 1 plus 1? Would the asymptote be
1? And you're going to do that example. So x, y, x, y. Just like a parabola, you always draw the original one first. What is our base? What is our base? 2. So are you going to draw an upward or downward graph? Upward. So our graph goes upward. 2 to the x. Now for the shifting, we are shifting the left one unit right. So what we do, we take this y-intercept and we go 1 unit right. Unfortunately, we don't know the exact y-intercept, so we just assume something. Okay? 2 to the x minus 1. Similarly, the right one, we take the y-intercept and it says go left 1 unit. So we go left 1 unit here. And we do the same graph. And again, we don't know our y-intercept, so we just assume something. 2 to the x plus 1. And we don't have a visible y-intercept horizontal asymptote, so this is the line. The original one or the transformation one, none of them can cross. Y equals 0. So I think my MATLAB requires you to draw the asymptote. So I'm going to draw the asymptote with a dashed line. Clear? Any question?
And so the y intercept will change, right?
For the new one, we don't know what's the y-intercept.
Also, okay.
So it doesn't have to be exact. Our main point is you're shifting the old one 1 unit or 2 units left, right. Okay, you try this. Let's say this is 2. E to the x plus 2 on the top and e to the x minus 2 on the top. Ryan, what would be the shape? Upward or downward? Why upward? Christian, don't say anything. Why it's upward? The answer is correct, but why? No, not because of the plus 2. Because of the base. What is your base? What's the base in this equation? E. That's the base. So is E more than 1 or less than 1? That's why we have an upward shape. Chris, for the left one, which direction we are going to go?
To the left one. We've got to go to the left.
To left. So we are shifting this point, 1 left, 2 left here. So in the exam, I want you to draw this shifting. Otherwise, how would I know which direction you went? So we shift the y-intercept 2 to the left and we draw a new one. So as long as I see that you move 2 units, then the shape, I will not care that much as long as it's an exponential shape. So it's e to the x plus 2. Gerald, for the right one, e to the x minus 2. Which direction you are going to go? Right 2. So you take this y-intercept. We always move the y-intercept. That's the main point in the exponential function. We take this y-intercept, we are going 1 right, 2 right here, and then drawing the same graph. 2 to the x minus 2. And that is e to the x. Sorry, it's e to the x, my bad. E to the x minus 2. Any question? Shifting by 2 on the left and on the right. Now, how about we have both of them together?
We move to right one, and then 3 up.
Right 1, 3 up. Since we are moving up and down, so we have asymptotes. What's the asymptote here? 1 point deducted. Why?
That's y.
Y equals 3. So we are going 1 right, 3 up. So let me draw here x and y. And what type of graph? Upward or downward? So this is original 2 to the x. The same graph we are going, before that, let's do the asymptote. We cannot cross 3 lines. So this is 2, this is 3. So this is the line we cannot cross. So we are moving this, let me change the color to blue. We are moving this point 1 right here, and then 1 up, 2 up, 3 up here. Do you see my shifting? 1 right, 1 up, 2 up, 3 up. So we end up being here. So this point goes here. 2 to the x minus 1 plus 3. Vertical asymptote, it doesn't have vertical asymptote. Log graph have vertical asymptote. Logarithmic and exponential, they're inverse of one another. So if exponential has horizontal, log has the other one, vertical. Who is confused here? Anyone? Anybody? Dua? Ask me a question. And we did not cross this line. For the transformation, we took the original of this point with the one right and then 1, 2, 3 up. So this y-intercept is now here. And our graph has to lie above this line. So through the same graph here. We do have a y-intercept, but we don't know how much is it. And for now, we don't even care how much is it. The original cross that transformation one, because this is the original one without transformation. It goes everywhere above that axis.
So the one that we're transforming.
The transformation. Yes. Because original one has an asymptote here. For the original one, this is our asymptote that we cannot cross. And for the transformation one, it's the above one. Yeah. Okay, for the next one, which direction we are going? Left one and then 3 down. Since we are going 3 down, what is our asymptote? Good. Now you get full 2 points. Y equals -3. So this is the original one, 2 to the x. The transformation one has an asymptote at -3 here. We cannot cross this line. So we are moving this point, 1 left here, and then 3 down. So 1 down, 2 down, 3 down. 1 left, 3 down is here, and we are drawing the new line 2 to the x plus 1 with a -3. So for now, we don't know what is our y-intercept. I could be wrong. The main idea is this is the new point here, the main point here. And if you want to find the exact y-intercept, substitute x with 0 here. So 2 times 0 plus 1, so 2 to the 0 plus 1 is 1. So we have 2 minus 1, which is 1. So if I draw it precisely, this will be the shape.
So 2 plus 0 plus 1. What is that 2 to the 1?
0 plus 1 is 2 to the 1, right? So you have 2 to the 1, which is 2. And then you have -3, which is -1. So a new y-intercept is -1.
Oh. That's how you find out?
Yeah. If you want to find the exact y-intercept, replace x with 0. For my MATLAB, you have to do that. But for in-class exam, don't worry about that. The main thing is this transformation. I am to see these points. As long as you show me these points, you're fine. Original one is 1 point. And the transformation is, reflection is 1, up down 1, left right 1. So transformation is 3, original graph is 1, and asymptote is 2. Dua. Weird means how weird. If you draw a parabola here, obviously you're not going to get point. Show me a picture. It's fine. As long as you draw exponential graph and you show your movement, you're fine. But don't draw a parabola here because exponential graph doesn't have parabola shape. Don't draw a line here because exponential is not a line. It's a curvy line.
When's the next exam?
Huh?
When's the next exam?
December 3rd, exactly 3 weeks from today. And I already posted the review sheet on Blackboard, sorry, on Brightspace. Let's skip this, okay, because you already got the idea. Let's go to the reflection.
Wait,
Huh?
is this all that we're gonna see on the next exam?
Everything you're learning after exam 2 will be in exam 3. Okay, so reflection. If we have a negative in the front, either front of the base or in front of the x on the power, we have two types of reflection. If you have a negative in front of the number on the base, then it's a reflection about y-axis. Reflection about x-axis. If you get confused like me, remember y equals x squared is a parabola and y equals negative x squared is upside down parabola. So we have a reflection about x-axis. The same concept goes here. If you have a negative in front, it's a reflection about x-axis. So let's draw this. X, Y. This is the original one. 2 to the x. Its reflection will go to -1. Negative 2 to the x. So this is your mirror. Whatever you have above mirror, you have the same thing below mirror. So above mirror or y-intercept is 1. That means below mirror or y-intercept has to be inverted. The same shape, it has reflected over x-axis. On the other hand, if you have a negative on the power, look at this cool thing. How can you convert negative power into a positive power? In other words, it becomes 1/2 to the x. See? So, what would be the shape for this one?
Automatically from 1/2 to the x.
That's why when your power is in negative, it's a reflection about the y-axis. So this is 2 to the negative x.
And that's also 1/2 to the x.
That's why we said when the base is a fraction, it goes downward. Why? Because when base is a fraction, our power is a negative. And when you have a negative power, it's a reflection about y-axis.
Why can't we just keep it a negative x? They can tell us that it's a reflection.
Because sometimes you see your base. Here, you think your base is 2, but actually your base is not 2.
1/2.
It's 1/2. And the thing, you may think it's 2, but actually the base is not 2 because our power is negative. See the trick? Cool, right? Do this too.
Yes. What if the power is 3 to the negative x? Would the base be 1/3?
3 to the negative x. 3 to the negative 1/3. And when you do all three transformation, remember your reflection always comes first. So you're going to reflect fast, and then you're going to move your y-intercept wherever you want to move.
So we're basically gonna have 3 lines on one graph. Because we're first gonna have to erase that one, and then we're gonna reflect it, and then we're gonna shift it.
You can do the reflection in mind.
Okay, so You don't want to see it? Okay.
The final one is fine because when you do the final one, it's a reflective one, shifting up and down.
Is already a reflection. Do we still have to convert it into reflection? Or do we should have the reflection and then move on?
You can do the reflection. But if you want, you can already see it's 1/2 to the x. You are shifting 3 units down. And in the final exam, you'll have at least one of these transformation. Yeah. You're done already? So tell me, what is the original one? Okay, so
now you will be a wire frame and goes down.
so this is e2 to the negative x, and you are shifting your y-intercept. So 1 down, 2 down, 1 down, 2 down, 3 down, and don't forget about your horizontal asymptote. What is your horizontal asymptote? Y equals -3, 1 point deducted. So this is the line you cannot cross, and you have your reflected.
What number is that line?
-3, because you're shifting 3 units down.
Also, it would be at -2, all that there.
2 to the negative x minus 3. Or if you want, you can say 1/2 x minus 3. It should go downwards more.
So like I withdrew the negative, or sorry, the 2 negative x, and then transformation, I didn't draw the regular 2x.
It's fine because you already see it's 1/2.
Yeah.
If you see it's 1/2, it's fine. So you have to draw at least one of them, either this one or this one. At least one of these. And there's the transformation. For the next one, what is the horizontal asymptote? Y equals -3. So -1, -2, -3. So we are not going to cross this line. And now which type of reflect? What?
x-axis?
If it's reflected about x-axis, then we have a problem.
No. I tried it.
Isn't it when the power is negative, it's reflected over the y-axis?
It's reflected about, but this one is reflected about x-axis, right? If it's reflected about x-axis, and we cannot cross -3, we have a problem. So our question has an error. Because look at here, if we reflect here. Oh, sorry, my bad. It doesn't have an error. Let's actually draw it in the next page because let me draw it in the next page. Because I forgot that I told you reflection always comes first. I forgot that. So let's draw it here. X, Y. So we know we cannot cross this line. It doesn't matter where our crossing is. We cannot cross it. Our graph may lie above or below that, but we cannot cross that line. Now the original one is this one. Right? First step, reflect that. So if we reflect that, this becomes our reflected graph. Right? Now we are shifting this point. How many units?
But we should be that point right there, the -1.
-1, because we are shifting the reflection, not the original one. First we reflect, and then we shift. So we are going one, which direction? No.
Oh.
One left. Oops, what is this? We are doing both. What's wrong? So this one, it's on the power. Power means left, right. Left, right means opposite direction. So +1 should go right, but actually go left 1. And -3 means down 3. And we reflect fast. Otherwise, it's wrong. So first step, do the reflection. That reflection, we are going to shift. One left means here. And then 1 down, 2 down, 3 down, mean here. The reflection goes 1 left, 1 down, 2 down, 3 down. So this is our new, this point comes here.
-5, right?
-5. But is that minus?
-4.
Yes.
1, 2, 3, 4, 1, 2, 4.
But
So
we
this
started at
point is -1, -4.
Minus 3.
We're shifting 3 units down. So this point goes. Oh, you wind us at -5, right?
Yeah.
I'm not talking about wind us, I'm talking about this point.
Oh, no, I'm saying that you
This point is -4.
Okay, yeah. No, I can. Then you.
So we draw the reflection here. If you want, you can find this algebraically. So look at here. This is the original 1. Reflection becomes -1, right? Now shift -1, 1 left, 3 down. So 1 left, 1 down, 2 down, 3 down. So this is our new point. And now draw your graph here. If you want to find the exact value, you can do it algebraically. Let's say for my math lab, you have to find exact value. So y-intercept -2, 0 plus 1 minus 3. That gives us -2 to the 1 minus 3. That gives us -2 minus 3. That gives us -5. So this has to be -5. Chris, which part is confusing?
I think I was just confused because the y-intercept in the original equation is 1.
1.
And then I'm
First
just,
step, reflect. So what's the new y-intercept?
y-intercept is -1.
Now that -1, you go left 1, 3 down.
So then wouldn't y-intercept be -4?
No, because you want that one.
You moved 1 down, 1 left. Since you moved 1 left, so this point
Oh,
was 1
because you're
left.
further.
So if you want to find the exact number, just replace x with 0 and see how much the y. For exam, you don't have to find the exact one, but for my method, you do.
You also have to find this kind of point on the final.
You have to indicate the point. If you don't indicate, how do I know like which direction you go?
Wait, which point will have to indicate?
This.
Okay.
But what about the one that's roughly applied to it for the final?
In the final, also the sketch. So sketching doesn't have to be perfect. Just a sketch.
Okay.
The main thing is, as long as you show me this,
Yeah.
you're fine.
Yeah.
I don't care about where you're going.
So what?
So this is 2 -2 to the x plus 1 on the top, and then you have minus g extra. And that's how you find the exact y-intercept, new y-intercept. Any question? So we are done with transformation. And now let's do backward. They gave us a transformation. Figure out which one makes sense. Question number 1. Did we learn about this yet? No. So definitely these two are out. Now which one makes sense? E to the x minus 1 or e to the x minus 1? If you have the first one, which direction you are moving the e to the x graph?
1 right.
1 right. And for this one, which direction you are moving the e to the graph? 1 down. So how do you figure this out? For this graph, what is your horizontal asymptote?
For the graph.
For A, what is the horizontal asymptote? Y equals 0, because you're not moving up, down. But for B, what is your asymptote? Y equals -1. In the graph, what is your asymptote? So what is your answer? See? With the asymptote, you can easily figure out which one. This one has y-intercept 0 because we are not moving up, down. But this one, we are moving 1 unit down, so our asymptote is y equals -1. Look at the graph. This graph, this function is above this line. It looks like it's touching. It looks like touching, but it never touches. Okay? It never crosses. So we have an asymptote here. So just by observing the asymptote, we can see our graph is big. Okay, we are done with graphing, transformation, everything. And now we are going to solve them. Solving exponential equation. Now for your convenience, I put together all the scenarios you're going to see. And I also wrote the steps down on how to solve them. So depending on what type of scenario you have, we take different steps to solve exponential equation. In the first scenario, we have the same base on both sides of the equal sign. As long as you have the same base, we are allowed to cancel them. And then we simply work with the powers. We set the left power equals to the right power, solve for x algebraically. In the second scenario, we don't have same base. However, the smaller base and bigger base, they have a connection. We can convert or we can rewrite the bigger base in terms of smaller base. For example, maybe one side has 4x, other side has 2 to the x, 2 to the 5. Okay? So you see our bases are different, but can you rewrite 4 in terms of 2? So we are going to rewrite 4 as 2 square. And do you remember the exponent rules? When you have two powers next to one another, how do you combine them?
Are they multiplied? Where?
Here on the left page.
Oh, they're next to
So we multiply them. So we cancel the bases and we write 2x is 5 and then solve for x algebraically. 5 have. So this is the second scenario. Our bases are different, but we can rewrite the bigger one using the smaller one. Now your third scenario. Both bases are different, but they have something in common. For example, you may have 4 to the x equals 8 to the 5. Now, can we rewrite 8 as 4 with some power? Not power. We cannot write 8 with 4 to the some power, but both of them we can rewrite using which number? 2. So we rewrite 4 as 2 square, and we rewrite 8 as 2 to the what? 2 cube. So this has x, and this has 5. So we rewrote 4 as 2 square and 8 as 2 cube. Because our goal is to have the same base, so we can cancel them.
Oh, so the base here wouldn't be 2 to the power, it would be 2.
Our base is 2 here, but here our base is 4 and 8. We cannot cancel them. So you rewrite 4 as 2 square and rewrite 8 as 2 cube. Now they have the same base.
So we cancel 5.
So we cancel them. And we get 2x is 15. No, the bases are gone.
The base was 2 to the power of 2 and 2.
No, base is only the number, base. These are power, these are power. So these two are powers, these are also powers.
That's just a power to a power.
Exactly. So power to the power means multiply them. And we cancel the bases. So that's the third scenario. We don't have the same base, but they have common base. So you rewrite them using the common base.
What if they don't have common factors?
Are you going to give us like really big numbers?
No, look a smaller number, like 2, 4, 8, 16, 32, those numbers. And the time table for 3.
Wait, say
The
that
time
number.
table for 2, 3, and 4, and 5. Okay, how about this one? They're completely unrelated. We wish, for example, we have 2 to the x equals 3 to the 5.
Who's in? Just apply in.
Nothing. It's
Ln. Ln means natural log.
Is it equals to 10 or what's LN?
It's Ln. Ln means natural log. In your calculator, you see a function. So this type of question you cannot solve without calculator. These two we cannot solve. Actually, not this one. This one we cannot solve without using calculator.
So that's gonna be.
Calculator version. Since 2 and 3, they're completely unrelated. So in order to get this x down, we apply its opposite, which is log. So we can apply either log or natural log. Ln means natural log. It's a log, special type of log, natural log. When you apply log to both sides, log takes power. Anytime you apply log with the power automatically comes down. And then we solve for x from there. We're going to do details later. I'm just showing you what are the types and what are the steps we take.
Log to the power comes down.
And the last one, they are completely unrelated, and one side of the equation has more than one term. So first, we are going to solve algebraically a little bit so that we only two terms on two sides, and then we are going to apply log. So these are the 5 types of exponential equation you are going to see, and you're going to solve. Now let's do them in details. The baby one, we have the same base. What do we do? We cancel them. Same base, just kick them out. Still left with 2x equals 3x plus 2. Now solve for x algebraically. If you want, you can do subtract 3x. So if you want, you can do negative 2x. So do I need to do 2x or 3x? I want to do 2x because 2x is smaller than 3x. So they cancel out. We get 0 equals x plus 2.
And then negative.
Subtract 2, and we are done. X is negative 2. We are happy. Since this is so easy, so you're not going to see this in the exam. It's too easy.
It's not easy.
Tell me which part is kind of
It's very
confusing.
confusing. I want to see it in the exam.
Oh man, you're tricking me. I believed you.
Oh, that one.
Next time, can we rewrite the bigger base in terms of smaller base?
Yes.
For 2, I think we'll put this one.
16 is 2 to the what power? 2 to the 4. So this is 2 to the 4. We rewrite and we leave everything else alone.
So
Now the left 2 has what here?
2.
No, it's not 0.
What? Yeah, it's negative 1. The same.
It has invisible 1.
Oh, so we're gonna put 1 instead of 0 there. I'm just.
And then you're allowed to cancel this. Give me 1 second. 1 is 4 times 3x minus 1. So 12x minus 12. Oh, sorry, minus 4, my bad. Add 4. So 5 is 12x. So x is 5 over 12.
We're gonna put, you know how the base is.
Why do you have no power in the one power always?
Yeah. No, no, 0 equals. I want to do
Break down the big numbers. If you break down big numbers,
Cancel the base.
because the base is.
And remember, the powers always multiply them. That's the exponent rules. Powers of the power means multiplication. Okay, you try one. If you're lucky, you'll see this in the final exam. Well, compared to the other food type, this is easy.
Okay, so that one in your mind.
Yeah.
Come on, let me try. No, let me do it. Okay.
Choose the paper. And then it's that one. If you're done, you have more. Are you done in the left page? Then try this. Back one and it's back up. So just for the left one, try these two. And one of these always comes in the final exam. I don't know which scenario, but for non-calculator, one of these will be in the final.
Can I try?
Of course. Let me come to you. I get check, but they don't want to check for yeah.
Do you want to check?
Oh, wait, they were three. Yeah, that's so chill.
Oh, you need to revise one.
It's really neat. I think it's number two.
Oh.
Seven is to what?
Um,
I think like, oh, you want to by them. In the right of the tower. 27 is 3 to the power what? If you multiply 3, how many times to get this number? You know? So it's 3 to the power 3 and this one. First one is and you know like this one. You inside and then outside. That's it. Talk about the left to 3 which is the time and 3. Good. Try this one. Give me 1 second. What do you have?
Oh, for
Left.
B,
Mhm.
negative one. X equals negative one. No.
You have the same mistake as Dua. You?
That's not great.
You did multiply the exact thing.
It's gonna be 3x minus 6 instead of here.
Yeah,
Let's
right.
see.
I said C. Yeah. My wording was.
What makes it different? And now we
Almost not that. It's going to take you on. Oh. Yeah, yeah. Always whenever a restaurant. I would guys.
Yeah.
Yeah, too bad.
Yeah, but I like it so much. I like it. Yeah.
Yeah,
I
it's
got
always hard.
36 for this, so maybe that makes sense.
I mean, we'll get another one. Like, just put it away.
Next time.
If it's not, if it's a new lesson, it's okay.
So we have the next type of question. In the next type,
Never mind, you can go back.
Wait, that's the same thing.
Talk about it.
so actually, let's do this one first, real quick. So we keep out 3, 2x minus 3, 27, we write 3 cube. Since you have the same base, we cancel them. We got 2x minus 3 equals 3 times x minus 2. So it's a distribution. We get 3x minus 6, 2x minus 3. Subtract 2x, add 6. I'm doing 2 steps in 1 step. So we had 3 equals x. Here, 16, we can rewrite So we keep the left. 16 is 4 to the what? Second. So we cancel the 4 and we have x minus 1 is 2 times 2x plus 1. So again, distribution 4x plus 2, x minus 1. So subtract x minus 2. We get negative 3 is 3x. We divide by 3. So our x is negative 1. And you can actually always check your answer if you want. If you want. We have 4 to the negative 1 minus 1 and 16 to the 2x negative 1 plus 1. So on the left side, we have negative 2. On the right side, you have 16 to the negative 2 plus 1. This is 1 over positive 4 square, and this is 16 to the 1. So negative 1. So we have 1 over 16 on the left, and on the right, 1 over 16. Because negative power turns into positive if you make it a fraction.
For the 1 over 4 squared, can we make that 1 4 parentheses squared? Because
You can always check your answer if you want.
it's recommended.
Yeah, if you have time in the exam, check. Now the third type of question. Our two bases are different. We cannot convert one of them into another one.
Just convert it to a smaller common.
So we think of a number. Can you rewrite 8 and 4 in terms of a smaller number?
Yeah. Sometimes 4.
So we have 4x minus 1 and 4x minus 4. Now 8 is what? No, with the power. 2 cube. And 4 is 2 square. So when you rewrite the base, we have to have a power, not multiplication, it's the power.
No.
Here we did 16.
No, yeah, in the beginning, when you showed all the moves. Yeah.
So this is the third rule.
Yeah.
We have different bases, but they both have common base 2. So 2 cube and 2 square. So we cancel our bases, so no more bases. We left to 3 times 4x minus 1 and 2 times 4x minus 4. And now it's algebra. Distribute. 12x minus 3 is 8x minus 8. Eight is smaller, so let's subtract 8. And if I want to do 2 steps in 1 step, I will get rid of the 3 here. But if you want to do it in 2 steps, go ahead. So we have 4x is negative 5. Divide by 4. Negative 5 over 4.
We don't have to convert that to a mixed number. So,
Keep your fraction. Sometimes they give this type of question in the final.
Will you give us two of these questions in next?
One of them definitely will be in the calculator portion, and I'll get 2. One of these and one of the other one.
Okay. One calculator, one number.
So before we go, try this. And they both have 8. Let me see if I have something different. Actually, say the next one, 9 and 27. because you already did 4 and 8. If you want to know the answer for the left, answer for the left is negative 9/2. So try the right side. Rewrite 9 and 27, both of them with some small number with some power. One more, try it. And if you look at your review sheet, you will see this question again in the review sheet. Dua. I don't have the answer here yet. But you can check your work. -9, huh? Oh, the first one? Last one.
For the last one.
Oh, for the right side. How much you have? This big. Okay, so Nazima got the same thing. Could be the answer, but I'm not sure. -16/3? Okay.
Oh, no, that's not gonna be right.
It's not right.
I don't think so. I gotta know the E inside of it.
It means it could be a big number.
Is it the same thing?
Tenzil.
No,
Tenzin. Sorry. How are you going to relate 27 and 9? It's okay, no problem. He already answered that. See the same thing, right, Stephanie? 3 and 3 See, we have the same base. Cancel down. You got it? So we have 3x and 12, 6x and 4. So subtract 3x, subtract 4. We get -16 is 3x. Yep. Our x is -16/3. Let's check. Let me do it here. It will be fun case. So we have 27 -16/3 minus 4. And we have 9 3 times -16/3 plus 2. We cancel these two. We get 9 to the -16 plus 2. That gives us 9 to the -14. And this one, we need LCD. So multiply top and bottom. So we get 27 -16 minus 12/3. That's -28/3. Now 27 is 3 cubed. And 9 is 3 squared.
Thank you.
So here we get -28. Here we get -28. Yep.
Thank you. So this Friday, I don't think we'll be able to be here. I've got this really like networking opportunity with politicians, and I thought I just can't turn this down. So, yeah, the class notes and everything, I'll just make sure. Stuff.
So after I post the recording,
This
make
is
sure
why
you
I
watch
said
it.
why I said it was a weird number.
That's because it's a big number. So it's due to the negative. It's a big small number.
But why you got -28? And it didn't say.
Because I did this.
Can you fix it so that it can tell me the numbers correctly?
It will not tell you because it has 13 0 in the front and then this number.
Okay.
E to the negative 14 means you have 13 0 in the front and then you have this number.
Wow.
So they don't want to write 13 0 in the front.
It has 13 zeros in the front.
Why? Because of this. The left side becomes 3
Oh.
to the power -28.
So that's what the E means.
Uh-huh. So it's 1 over 3 to the positive 28. It's a very small number.
Oh. Okay.
I'm gonna email you 10 minutes or 5 minutes before officer.
Just knock on the door.
The one that we went in.
The one you
That's
got
closest.
in closest to the door.
Okay. So I just wanted to double check for the description because when it's 2 to 1 power, you just
It's 1.
Okay.
So 2 to cancel out, you left it 1. That goes on the left
so
side.
it can never be like 2 to the 0.
Right.
Thank you.
You can put 2 to the 0 if the left side is 1, only 1. Like 1 equals that. So we can rewrite 1 as 2 to the 0. So you can write 0 is one side and the other side is the number.
You said -5 is like the point is not on -5 or is
So your intercept, your asymptote is -3
yeah, so we start
and
at
your graph
negative-
is very low. So something is wrong with your graph.
so we start at -1 and then we move down 3. So that'd be
Right, so this is -1, 2, 3. So this is your reflection.
and then
And
move down
-3 you cannot cross. So this is the line you cannot cross. Now
Oh, so we
that
still
negative
start
one-
at so we still start at 0 and move down to 3, not
no,
-1.
we start at -1.
Yeah,
We go 1 left and then 1 down, 2 down, 3 down.
yeah.
So this point comes here.
Mhm.
So you draw the line here.
That's not the asymptote.
The asymptote is this one, 3, -3.
-3.
See here? That's the asymptote.
Then for this one, similar for this, we move down.
It's
I
just
mean,
a
it's
reflection,
yeah. So
but we still have no left, no up down. So this is our
asymptote.
asymptote.
Um,
So that's it, it's your plan. It's always better to draw the asymptote first, and then you draw the other things. And when you have a reflection, you should always reflect first, and then move from that reflection. Next class. What is this class? 19. Overwhelming information.
Huh?
Overwhelming information. Is the information too much?
This?
Mhm.
Oh no, it's not. I was just confused how that.
Okay, we have 15.